Hi everyone, I'm Julia Heider, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by MachineMetrics. Manual data capture continues to plague manufacturers. This band-aid approach to data-driven manufacturing not only forces operators and other personnel to capture and compile data, but also leads to delayed and inaccurate information. In this webinar, a leading medical device manufacturer, Orchid Orthopedic Solutions, will share their story of transitioning away from paper-based documentation to automated production monitoring. Our presenters today are Ryan Soles, Joshua Refines, who are both manufacturing engineers at Orchid Orthopedic Solutions, and MachineMetrics co-founder and CEO Bill Bither. Ryan is a MachineMetrics champion at Orchid in Chelsea, Michigan. He strives for continuous improvement and the use of technology to replace manual processes, relying on the data from MachineMetrics to make data-driven decisions and improve processes. Josh is a manufacturing engineer at Orchid in Chelsea, Michigan. He works to update existing processes to collect data and information and present it in a way that helps people make informed decisions. He is interested in using modern systems and tools to automate existing tasks and bring previously uncaptured information to light. Bill is an experienced software entrepreneur and manufacturing technology leader. After spending his early career as an engineer for global aerospace manufacturers, he founded Italisoft to image-enable web applications, leading to a successful exit in 2011 to Kofax. Returning to his manufacturing roots, Bill co-founded MachineMetrics in 2014 to bring visibility and predictability to the manufacturing factory floor. You can submit questions for our presenters at any time during the presentation using the Q&A tab on the right, and we'll answer as many as we can at the end. We also have a poll, so keep an eye out for that so you can answer it. And I finally wanted to let everyone know that this webinar is being recorded and attendees will receive a link to the recording via email. So with all of that, let's get the presentation started.
Great, thank you very much for the introduction, and great to be here with Orchid Orthopedic, and let's get started. So we went through the introductions here, so I'll skip through that. But basically, I'm going to give you just a few-minute overview of MachineMetrics for those who aren't familiar, and then hand this off for the real core of the presentation to Ryan and Josh to talk about how they've implemented MachineMetrics, the value that they've received. And we'll wrap this up with some Q&A. So first, let me really introduce what we consider the next generation of production analytics. MachineMetrics is a production analytics platform that makes it really easy to capture data from discrete manufacturing equipment. So think like CNC machines or plastic injection molding, stamping, presses, that sort of thing. And we automatically contextualize that data so that you can drive value, you can increase visibility on the plant floor, and really take the necessary actions to improve your throughput and machine uptime. And we look at this as more than just machine monitoring. Really, we're automatically capturing and generating insights from the data that we're capturing from the machines, from the plant level or the enterprise level, all the way through the plant level and down to the machine. And you'll see some examples of that in this presentation today. So the first thing I wanted to touch on is machine connectivity. So in order to leverage this data and this automated data, you need to have a really good connection to your machines and really have an understanding of what those machines are doing, what they're producing. We've built a number of connectors to different CNC machine controls, but we also support standard protocols such as MT-Connect, OPC-UA, and so forth. And this makes it easy to connect to these machines and capture data. Generally, we can connect to a plant floor with maybe 100 machines. It takes a couple of weeks to get all that data captured and gathered and connected, and then you can start really leveraging that for plant value. So there's two really main areas of the product. One is in condition monitoring, where we're taking this data and we're basically looking to see if there's a problem or a condition that requires action, and then you can set that up to then create a workflow, such as an alert or connect to another system like a maintenance system to take action based on certain criteria. This is we support various sensors such as like IFM, IO-link sensors, if you're not familiar with that. And some example use cases that we see here is like if you have a CNC machine and you have a coolant that might overheat, you can use a temperature sensor for that. Take action when that temperature exceeds a threshold. Same thing, if you're working on a CNC machine and you have operators that will maybe keep the feed override accidentally low, you could set a condition for that as well. As an example for condition monitoring. Today, we're going to be talking more about production monitoring and production analytics, and really where the industry has come, where traditionally we've seen a lot of pen and paper tracking of your production. And this is the case in our presenters today with Orchid, at least initially before MachineMetrics. And then software systems have often required that this data is still captured manually. There's a lot of operator input. We've built the intelligence into MachineMetrics, so there's no manual input required, and we're using the context from the machine to understand what's running, with human context as needed to really understand your cycle times, your downtime, how many parts you've produced, various machine conditions. We can even get down into the work order level with an integration with your ERP. So, and just to touch on that a little bit before we dive into the core of the presentation with Orchid. This is some of the data that we're automatically surfacing. Essentially, we baseline your performance over time. So we can see your OEE performance. That's the availability, performance, quality. It gives you an overall performance metric for your organization. We'll automatically track that without any manual input and give you a baseline on the current machine and all machines, that you can tell how your current run is performing and how that compares to other machines that are running the same part. We can also baseline your cycle times, so you can quickly see if you're running your part to your cycle time standard that's stored in your ERP. And you can see in this example, our standard, we're actually running a lot slower than our standard. We can also compare against your essentially your normal cycle time to how you've run on your current machine that you're running. And if you have run this on different machines, you can tell, like in this example, we're running a little bit slower than on your other machines. We also will track touch time. So if you have a manual process to remove the part from every part, we can see in this machine we have 6 minutes, but we're on your other machines, you're actually running that a bit faster, a minute and a half faster. So you can see this data without, just by connecting MachineMetrics, configuring it, no input required. Here's an example of some of the cycle time analytics that you would see. So you can, instead of having to track this manually with a stopwatch, this data is automatically captured so that you can run a deep analysis, look at all of your outliers, and really find out why you might have some scenarios where your cycle times aren't as expected. And finally, we'll show you the historical trends, which can really help in your coding performance. You can tell which machines are running at what cycle times and what performance, and this can help you identify problems and also see trends in your production. So MachineMetrics, we've been around for a handful of years. We have customers worldwide, really focused in medical device manufacturing, heavy industry, aerospace, automotive, really where there's a lot of metal or plastics manufacturing. We have hundreds of customers. We've connected to thousands of machines, and we're out there. We're growing fast, and happy to present our customer Orchid. Ryan and Josh, who'll be talking about their implementation of MachineMetrics and a little bit about them. So, without further ado, Ryan and Josh, I'll let you take it from here.
Okay.
Oh wait, actually, there's one more thing I forgot. Sorry, yeah. We actually had a poll, and I skipped right over it. So I guess before we jump in, we do have a question on how you are currently tracking production. You'll see a question pop up on a poll, which is, are you capturing data manually? are using a software system such as an ERP system to track your production that requires manual input, or we like to know, are you able to automatically track your production without any operator input? We'd be really curious to know how you're running your operations right now. So you'll see that pop up on your screen, and then I'll hand this off to Josh and Ryan now.
Okay, good morning, guys. I'm Ryan. And quick little introduction of Orchid. So, what do? We're a contract manufacturer of medical devices and instruments, and then we're obviously located in Chelsea. We're part of 11 other sites globally, and then our site is a 31,000 square foot just plastic machining site. Currently, we have 54 mills, or sorry, we have 54 machines. There's 41 mills, and then we have 13 lathes that we have. Over on the right is a couple listings of like forging, casting, other machining. There's coating and additives. Those are other sites right now, and we are the main site at Orchid that has taken on MachineMetrics, and we have implemented throughout our entire site. So, okay, go ahead, Bill. All right, thank you. Okay, so kind of like where we were before, we transitioned to MachineMetrics. We started out with hour by hour sheets, and so every single machine would have hour by hour sheets, and with that, every single operator had to fill out these sheets for every machine. In total, for our entire site, that adds up to about 22 and a half hours per day of just touch time on the machines and operators touching the paper. Okay, so that was no production was able to be had at that time because we had to fill out our hour by hour sheets. So with that, we compiled the data, and when the data was compiled each morning, our lead, it would take him about an hour to an hour and a half of touch time on the paper to actually record everything and input into an Excel, which then would be presented out to managers and other people. So the reason why some of those times were so long for that hour and a half session was not everybody was filling out the hour by hour sheets, so it was missing data. It was also sheets were just not there. They'd fill them out, but then they'd fall off of the table. They'd slide under machines. They just couldn't find all the papers. So there were some things that we were able to transition to that saved a lot of time. All these sheets were scanned in afterwards, so we could have a record if we needed to go back and pull data for root cause problem solving, and that seemed to take quite a bit of time to gather that data for some of our root cause problem solvings. And go ahead, Bill. Sorry, skip to the next one. All right, so now where have we transitioned to? We've transitioned from inputting for 22 and a half hours in the day and an hour and a half for our leads each morning to now there minimal entry between our operators in the tablets. They actually have to interact with the tablet as if there is a downtime set right now for more than 5 minutes. That's what we ask for is, hey, it's a quick little, there's already displayed downtimes. They can just select that and it categorizes your time. There is no hour by hour sheet, so that is obviously our good thing. And then now when we gather our data for production numbers in the morning, we use an API that pulls from MachineMetrics, and it inputs everything into an Excel sheet that we've externally pulled to, just so that we could customize our sheet for how we break our product family down. And this takes our lead now only about 30 seconds per day. He literally will type in what is the date that he's trying to capture and hit a refresh button, and it pulls all the data and inputs into an Excel sheet. So that was a big time saver, not only for our operators having less interaction with the actual paper, because now it's all captured every hour, every piece was captured within their hours onto the tablet. But now, yes, the lead is also able to speed up his time. The other way that we are actually able to benefit from MachineMetrics that we had seen just from right out of the gate was what we use as workflows. So these workflows are like these individual alerts, and you can alert different managers, leads, there's engineers without even having to go find them. So that was one thing that we tended to get caught up with was a person has an issue at the machine, and so then they go around and they're searching for somebody for an hour trying to figure out where is this person at. Oh, they're in a meeting. And so now they're able to just sit at the tablet. If they have a problem, they click our workflow button and they ping whoever they need to come to the machine, and that person responds pretty quickly. So we're able to save time and keep being productive because they could run another machine while they're waiting. And then let's see. So I'm going through here. So pull part number, cycle time. Okay, yeah. So the last thing that we end up doing here is we use all this data now to be able to pull all these part numbers with all their cycle times that we had per machine, and we actually can update our standards. So this is one of the quicker processes that we now can quickly again pull into Excel and then manipulate the data to show what part numbers we need, how many times do we run it this past year. Before, all of that was manual. I had to go through and take all these PDF files and go, okay, what was our part number, what was our cycle time, and manually enter those into an Excel sheet to update our standards. Now it's just a quick pull. So we do this, and it only takes about an hour or so to kind of like pull this data and then walk through and verify which was our biggest issues with our routers, or if we've decreased cycle times, then we're able to show the benefit there and update our standards. So, okay, Bill, and you are all set there.
Okay.
Oh, is it on me?
Oops.
Because
Is
there
the
we
right
go.
slide?
There you go.
Yeah, that is. It's just a delay.
Yeah.
So this is an
Okay.
example of the sheet that we use, part of that automatic data pull that Ryan talked about. This is basically the same version that the manual sheets were used to fill out. So the lead would go through each manual sheet, find the machine. You can see our asset numbers on the left. Those are all the individual machines in this particular cell of the floor. And then they would enter in first shift, second shift, third shift pieces. We have columns in each piece because some of our parts were multiple operation pieces. And so we wanted to count those as production when it came off the final operation as opposed to the first operation. Um, so what this API does is MachineMetrics set us up with their academy, which got me to learn what an API was to begin with, and then also how to program a query into Excel. Basically, just walk me through step by step, a lot of copy paste to pull the data that we needed for any particular day. And so what I was able to do is basically take the same form, put a date entry up in the top left corner that you can see there. They click refresh data, and then this will automatically populate it in for whatever date they selected. The historical data is nice because they used to have this Excel sheet and they would add a worksheet for every working day. So as we got towards the end of the year, you would literally have, 150, 200 tabs in that file, and it can be really tedious to go through and find historical data. Now, if you want to know what happened on December 3rd of 2023, you just enter that date up and it'll pull the data from that day. We then take this and what we do is we treat our products in what we call wheels or buckets. And that's kind of this colored section here is so we have a second query that looks at, okay, what was the part number? What bucket does it belong to? And then so it totals up each of the pieces from those buckets every day. And then we actually take that same information. If you go to the next slide, Bill, we take that same information. We're able to produce a weekly chart that shows, okay, we know how many pieces we need to produce of each of these buckets for the week. This kind of shows on a day-to-day basis where we are cumulatively throughout the week. So leads can see, oh, product one, product two, we've already hit, let's say it's Wednesday, we've already hit the pieces that we need from those buckets. We can shift operators from product one, product two, and move them over to machines that are maybe running product three, product four. Like most people, we don't have a one-to-one man-to-machine labor um, availability. So we have a lot of operators running multiple machines. So it helps us kind of shift and make those decisions that help us handle what we need each week. And again, this is using the API. It'll update automatically. So you punch in the next day, you hit the button, refresh, it updates the chart. And this is presented to our plant communication board every day. Go ahead to the next one, Bill.
Okay, so where would we like to see ourselves going here in the future? There's a couple places that we've already started transitioning to. So before there was this auto, or, I mean, sorry. So what we're working toward is to get to an automatic part recognition on each machine. So therefore, the moment our setup person types in the program that they're about to run, it will automatically pop up the correct part number and size or thickness, whatever, and then it starts categorizing parts as that new part number. Before, and this is on half of our machines still, we have to manually hit that button. So we have to hit setup and then we type what our part number is that we want it to display. And then we type in like our work order number or our job number. Um, we're getting to a point to where we're starting to transition to this automatic part recognition. And right now we have it on 12 of our mills. As of this week, we've actually turned on 4 more mills. So now the part recognition is on 4 more. And so we're working to kind of move this throughout our entire shop. So now this is a little bit less interaction from setups to the tablets, and then they can focus more on actually getting their setup completed. So the moment they type in their program, it automatically pulls the part number up and starts counting parts under that bucket. So and then our next step that we're also working toward, and we've been working with MachineMetrics almost every couple of weeks. We're on a call with them, but we're working to integrate the way our CMMs talk to MachineMetrics. So right now, anytime we scan a part on any of our CMMs, we're trying to work to have the tablet be notified. So then the tablet will pop up and say, "Hey, your part is completed," or it's finished scanning. So these are things that we're working toward in the future. Once we make it through that phase, I think the next phase would be, okay, can we now get it to talk and say, was your part in tolerance or out of tolerance, and let that tablet be notified like that. So there's some things in the future here that we're working toward, and MachineMetrics has been extremely helpful. And anytime we have an issue or anything going on, they're usually right there to help us out. So quick responses, and that keeps us continuing to get better at our site. So go ahead, Josh. I'll let you take over.
Yeah, so one of the things we're looking to do next is, so right, we previously had the interaction with the tablet where the operator would have to first punch in the part number and then punch in the work order number, and then also they'd have to interact with the tablet to keep track or categorize any downtimes. So what we wanted to do is kind of move away. What we found sometimes is that operators weren't as consistent with punching in the work order, or sometimes they forget to add a part number until they were halfway through the job. And so then you'd kind of have these like 5 or 6 pieces hanging out in space where MachineMetrics didn't know what part number it was. And by putting in the automatic part number recognition, we solved that problem. We want to take it a step further to where we can have MachineMetrics look at our ERP system and be able to determine what the work order is based on what machine it's running on, due dates. We haven't gotten this far yet, but we're working towards being able to automatically recognize what work order is running based on part number, machine, and schedule. We're also talking about being able to move our labor reporting from directly into our ERP system to where the operators can log in as individuals on the tablets of the machines they're working on. And then when they clock in on that machine, it would then report that to our ERP system as their clock in for their labor and productivity. That's kind of how we track and measure our operators on the floor right now. So we would automatically record labor. They wouldn't have to interact basically with our ERP system at all, because the third step, the scrap reporting, is also a functionality on the tablet. So when they do have a scrap part, MachineMetrics runs, it counts a part, and they say, that part was scrap, would then bring up a touch screen menu that'll say, okay, what's your categorization of that scrap? And they'll have like 8 or 9 entries, what we call pins codes. And those codes go into our ERP system as well. So when we run a scrap report in our ERP system, you can see, okay, we had 10 pieces scrapped for dimensional issues, 3 pieces scrapped for cosmetic issues, 1 piece scrapped on setup, and so on and so forth. So that's kind of where we want to go in the future, is more integration with our current existing systems. And then also the one half of the daily productivity or daily production report that I didn't talk about too much on the right side is we also collect downtimes. So the operators that categorize their downtime, they're kind of gathered into 5 or 6 buckets. What we want to start doing is doing a better job of looking at those buckets and where the high downtimes are, what those causes are, and do an investigation as to why is that happening, what can we do to eliminate it, what can we do to reduce it, and kind of help drive improvement projects from that data.
Great. So before we go into the Q&A session, actually, I'll go back a bit. Thank you, Josh and Ryan, for that sort of deep dive into how you're using MachineMetrics at Orchid. I just wanted to just summarize a bit. What we've found, and we've been working with Orchid for I guess about a year and a half now on this, is that even well, number one, we're incorporating real-time data into their daily process, their daily Gemba walks. And by pulling data from our APIs into the existing Excel sheets, the whole team is able to use what they're familiar with real-time data. And as you saw before, that saved, I think, what did you say, like 22 hours a week in administrative time just in that data collection.
Yep.
So that's a pretty big savings just on administrative savings. Not to mention that this data is more accurate. It's live. You can really take action on it right away. There's so much other opportunity to generate other use cases, like tying into the CMM machines. There's other use cases that we're tackling over time. But the other thing to point out is that the data at Orchid is somewhat complex. The programs that are running, each program can have I guess an infinite number of sizes, or at least quite a few number of sizes. We're able to pull that from the programs, and in some cases it's really easy. The data is right there. In other cases, it could take some modifications to like the program header. We do everything we can using AI and machine learning to minimize any program changes that are required, and we're seeing great success there. But you do need to have some indication of what's running in that program for this to be automated.
Yeah, just to further on what Bill.
Okay.
I would say just to further.
No, go ahead, Josh.
Saying is that basically we have part families that essentially we could have 10 parts that all run the same CNC program, and there's just a macro value that the operator will change to change the thickness of the part. And so the problem was well, when you have 10 parts being manufactured by one CNC program, how do you look at the CNC program to determine what that part number is automatically? And the solution essentially said, we talked to our programmers and they said, well, we store that height value in this specific, what I forget what the term they call it is, but this specific
macro.
It's not a macro. It's I forget what it's called, but basically there's a certain value in the program that the operator updates. And so now what MachineMetrics is able to do is, okay, we pull the generic or the family part number, the first 8 digits of the part number from the program header, and then we fill it in plus the 3-digit value from this macro that the operator's entering. And so by doing that, we're able to identify parts, consistently, and it's working really well for that particular product family.
Yeah, exactly. So yeah, and then the result is automated data collection and also recognition of parts, as you pointed out, where those analytics that I presented earlier are completely automated. So great. So now let's open it up to Q&A. Feel free to use the Q&A feature. Ask any question that you'd like, and it looks like we have a couple of questions that we can go through right now. Let's see.
I just want to say thank you, Ryan, Josh, and Bill. Like Bill said, we're starting to get questions. There's still time to submit one if you want. You can use the Q&A tab at the right to do that, and we'll do our best to get to it. But if we're not able to get to it today, someone can follow up with you via email. So yeah, looks like our first question here is, does MachineMetrics count the parts automatically, or does it need an operator input?
No, so
yeah.
MachineMetrics will count parts automatically. One of the issues we had at the beginning is we were seeing double counting of parts. And basically the out of the and Bill can correct me if I'm wrong here, but basically MachineMetrics was looking for a particular line of G code to know when the cycle had ended. And the way that our programs were written, and because we use a lot of sub programs, is that when a sub program ended, it would count that as a part ending, and then that same G99 line would come up at the end of the part, and it would count 2 parts for one. So what we had to do was we identified a value that we weren't using in any of our programs, and we've now set that as the standard of whenever you end the program and the part ends, we want it to count. This is the line you put at the end of the program, and so now our parts are counting 1 to 1 every time. The other issue that we had is we sometimes we would have machines run a warm up program. So it was called program one. And we were able to, in MachineMetrics, say, hey, if you see program one running, don't count any of the parts. And that got rid of some of the false counting issues that we saw. This is like in the first month of running MachineMetrics that we saw and we're able to fix.
Yep.
And that's part of our the data verification process that we go through with every customer to make sure that we're getting the right data, because there are some configuration tweaks that that are often required. It doesn't always work right out of the box when you connect the machine. You need to make those changes to make sure that data is perfect, especially if you're going to be using that in your automated reporting.
All right, next question. Isn't your ideal cycle time relative to the product being transformed and further by which machine it is being transformed on, when you can make the product on more than one machine? So I guess it's asking how you calculate ideal cycle times.
So we are a low volume, high mix shop. So our average lot size is, I don't know, Ryan, would you say like 30, 50?
Between 50 and 200 pieces. So
Higher than I thought. But
Yep.
what our ideal size, so what we do is our machine, we have very similar machines. So we basically have 4-axis machines and 5-axis machines, and then they vary by how large the bed is. So and then also because of some of the requirements of our customers, our part numbers are tied to specific assets. So pretty much we don't see there's not a lot of options when it comes to what machines we run what parts on. So our ideal cycle time is basically what's the best that we could do. If we ran this, if we had a guy standing there ready to replace parts, what's that cycle time from start to from button to button? So when you hit start of part one and when you hit start of part two. And that's kind of hard coded. That's what we use in our ERP system for standards. I think we add like a minute for part exchange, and then we enter that into MachineMetrics. We initially did. I guess Ryan, can you speak to how we ideal cycle time?
Yeah, so how we originally, they kind of go off of what does it take for a program to run when it's going through like software, and then they try to come up with an estimated part time, and then we essentially, after running the product, we can then make updates to it and be like, okay, nope, things in the program ran slower at this time, we have to make updates. But what we do is we go in once a year and we verify our standards in our ERP system to make sure that things aren't drastically off. We want to be able to schedule accurately, and we also want to be able to get productivity the way that everything is calculated here at our site with earned standard hours. So to be able to be accurate, we have to make sure our standards are accurate. Otherwise, if your standards are off and it tells you it takes 2 minutes to run a part, but it takes 10, you're never going to be able to be at that 100% productivity for that machine ever, because your cycle time is just way too slow. So things like that we do try to keep up on.
And this question might have been keyed off of the earlier slides that showed that there is a difference between the expected cycle time and the ideal. So what Josh and Ryan are speaking to is really the expected cycle time, which is the standard in the ERP, which is reviewed every year and then updated based on the actual data. But MachineMetrics also automatically calculates the ideal cycle time, and that's used in your OEE performance numbers, and that is based on whatever machine can run that part the fastest. So, I know in an example, I believe you have this example, Ryan and Josh, where you have some machines that can run a part with robotics that will have a faster cycle time versus those that are manually fed. And you'd see that in the data where you have certain machines that would run the parts much faster with less or no touch time. And that is surfaced automatically from that data, because we do calculate that ideal cycle time based on the whatever machine can run that the fastest.
Okay. Next question. How much did MachineMetrics have to support Orchid in their journey? It seems like Ryan and Joshua are both strong in their respective roles. Hats off to the Orchid team.
Thank you. Yeah, I would say MachineMetrics played a big part. When we first started, we trialed 10 machines, and we ended up trialing 10 for about a year. And we worked through a lot of different scenarios and how we could move forward with MachineMetrics, and is this going to be a good fit? And this essentially checked every single box to be able to eliminate those hour by hour sheets, because everything we were capturing was now digital and much quicker and easier to get to. So then once we went that route, we had check-ins. I think we were doing monthly check-ins, kind of like working through processes and connecting machines and doing things like that. And then once we got the okay at our site to turn on all machines, yeah, we were able to connect every single machine in about 2 days. And then after we got every machine connected, we continued to do check-ins, because there was little things that would come up. There'd be like a connection problem on one of our machines, and we'd find out it was something we did, we didn't verify right, like the 80, I think it's 8190 or something like that. But anyway, so there was a lot of kind of hand holding in the beginning, but now we kind of bring stuff to them like, hey, this would be beneficial if you guys could do things like this. And MachineMetrics takes that back. Then a couple months, I swear they add what we're asking for, and then it's in there. So, and we're able
Yeah.
to use the data.
Yeah, so I have no coding or programming experience. I didn't know what an API was. I like to make the joke that I'm just a monkey smashing at a keyboard until something comes out that I'm looking for. But walking through that initial tutorial on the academy got us set up with that initial API. But since then, I've always been coming back asking questions, saying, "Hey, well, could we get this data? Could we get this data?" And surprisingly, I forget his title, but I know it's rather up there. But they were really quick to put me in touch with Jacob. He's kind of like one of their top guys over the programming side, and he worked with me in like a 30-minute call to develop basically we look at daily production. I also was working on I'm working on now end of shift report, where our reporter our leads can just hit a button. It will show the current status of every machine. Is it in production? Is it idle? Is it in setup? And then how many pieces it produced for that particular shift. And it was something a little different. It wasn't as straightforward as I thought, and he was really helpful in getting that pulled together. And we got a solution put together in like a week or two, I think.
Yeah, and I think it's important to point out that you could see, based on that question, Josh and Ryan are really strong champions of the product, and that is extremely helpful. You can really take it a lot deeper when you're using APIs. But there's also a lot of the out-of-the-box capabilities, right? So you can generate reports, with drag and drop interface. You'd have that data, but to pull that into your own existing spreadsheets, that's where the APIs can become really helpful to use as
Yeah,
existing
we
systems.
do have some people come to us. Hey, can I get this data for this sheet? And we'll show them how to build a report inside MachineMetrics, and they can either view the report data there, or they can drop it into an Excel table. I know we use that for a lot of. We have a couple projects that we're tracking, improvement projects, or what we call productivity projects. So one of the examples was, how many parts are we getting during lights out? And so I help show him how to build the report in lights out. So every week he can go in there, runs the report, gets his numbers, and he's able to report out to upper management how much time do we save, or how many extra pieces did we get running lights out versus what we were doing before. And it's really nice, for at least from an engineer standpoint, to be able to show, hey, this thing that I did, here's the value that it provided, and you can kind of show tangible data on the actual improvement you made.
All right. Were there other software packages that were reviewed, and what set MachineMetrics apart as the solution that was chosen?
In the beginning, I can't remember. There was a couple others that we were actually looking at, but the interface for the operator, what the operator had to deal with, was very complex. And the good thing about this going with MachineMetrics was everything was just so simple. And literally, if you have a cell phone, you can work the simplicity of the operator interface. And that was one thing I actually had to sell to a few guys on our floor, because we have some older gentlemen that are like very stuck in their ways, like, nope, I'm a paper pen kind of guy, I don't do technology. And then literally once I showed them how easy it was, they were like, oh wow, this is easy, this is way easier than what I'm doing. So yeah, there was some things reviewed, other companies reviewed, but yeah, MachineMetrics kind of won with simplicity, and then also kind of just their personability, like we're able to just reach out to them at any time, and then that also helps sell. The fact that they're quick to respond. So.
Okay, not clear on the multi-part/machine question. Can you track variances by specific machine on a part basis? One machine with slow parts and fast parts, the ideal is different.
Yeah, I think I answered this in text, but yeah, I'll repeat that here. That we do track what your part cycles are for every different machine. So you in one of the slides, in fact, I could probably quickly jump back. You could see this information represented in the these different machines have different part-to-part active and touch times, so you can track them independently. So you'll know which machines are running faster and slower, and what those trends are.
All right. Did Orchid have a target ROI formula defined at the onset to the project, and was the target achieved?
That one's probably for you, Ryan.
Yeah, that was a difficult one in the beginning because we were trying to figure out how could we. And so when we originally did our cost savings, we just essentially eliminated our paperwork. And it was like, all right, how much paperwork time is it? Or like how many pieces are we unable to achieve while filling out paperwork? And then if we were to remove that, how many pieces could we gain? So with those, we took it off those based on the first 10 machines that we had going. And so we did a little cost savings based on those specific product family there. And we were actually able to achieve our ROI because not only were we able to eliminate our paperwork, now we were able to keep the machines running. And we actually, I think we went from, I believe we were at like 27% or 28% utilization on those 10 machines, and we were able to get those up to 47% at one point. So we were able to move that right up, and it was the same product mix, so things got a little quicker. The operators didn't have to walk away from the machines when actually having issues. They would hit that workflow button and ping somebody. That person would then be to the machine. They're able to continue working on the machine right next to them, making products. So now instead of 2 or 3 machines sitting, you could at least get your other 2 continuing to run until someone shows up to assist with your third machine. So things like that were able to help justify that cost there. So
Okay. How long did it take to connect the machines?
okay, so to actually go and connect the machines, it depending on what kind of machine you have. So for us, we have robo drills, and a lot of our robo drills are newer. I think our oldest one is like a 2013 or 2012. So for us, it was almost, we had to go in and verify there was maybe a 8193 in the machine was connected, and it had to have FANUC focus too. And so with those two, our machines essentially came with that already because they are FANUC robots or FANUC machines. And so when we just turned it on to work, almost 90% of those automatically just started connecting.
So we
The
have
Yeah, go
we
ahead.
pull our programs through a network, and all of our machines, or most of our machines, are Ethernet capable and connected, and so they have an IP address that matches their asset number. So like C83 ends with a blah 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 .83 or .083. So what we did is just go into MachineMetrics and say, hey, here's the IP address. Put in the IP address. It's this machine. So for our newer machines, or the ones that at least had the Ethernet capability, it was a matter of minutes to get those machines connected.
Yep.
Okay. What benefit can an ERP integration have?
So we sometimes, so when we're looking at data, we're making our decisions based on this data. The integrity of the data is very, very important. And so one of the things, I don't know, Bill, if you could flip back to the sheet, that Gemba sheet we had. Um, we actually noticed that sometimes we had parts that weren't categorized. Basically, they didn't have we have a separate basically I don't you call it, an index that lists all of our part numbers and what bucket they belong to. And if there were some new part numbers that came onto the floor, or things that maybe were obsolete and then became active, and they weren't categorized, they would show up in that top right corner where it says uncategorized pieces, and that will alert us right away that we need to go in and add that part number to the sheet. So,
the master list,
we knew that
essentially.
we were missing that piece of data. We also run into a problem sometimes where the operator won't type in the work order number. So we'll know how many pieces were produced, but we won't know necessarily what work order it's on. And in a lot of cases, we might want that information either, some further down the line, or maybe, this week we need to know what jobs ran and what jobs don't. So it would be great from what we would like to do is instead of relying on the operator to punch in that work order, to automatically pull that in. And then one step further is once MachineMetrics then tabulates all the pieces you've made and how much time you spent doing it, plug that back into the ERP system so that you could essentially eliminate operators clocking in and clocking out, at least our machine operators from clocking in and clocking out of each operation. It could do that automatically for them. And I know our operators would be in favor of that, just less that they have to do. They don't have to leave that. We have shared computers that they use to do the clocking in and clocking out, so it could be kind of annoying. I think it would be really great for them to be able to do that, and it would also help really shore up, make sure that all the data we're getting is automatically categorized, labeled, and we can really rely and know that everything's there that's supposed to be there.
Yeah, and to summarize that, like the ERP integration is really required for that work order automation. If you really want to know what work order is running, if you're planning on that running on a specific machine, then MachineMetrics can take that data and then tag that part that's running with a work order.
All right. We have one more question here. So if anybody else has anything they'd like to ask, make sure to get it in while we're covering this. But how long does it take to train someone to use the operator dashboard machine tablet view?
Okay, so I guess I could do that. That really took about 5 minutes. Literally how simple everything was. I wish you had a snip on here, but it literally will tell you how many pieces are expected, how many pieces you've actually made, and then at the bottom there is a start or like a setup or production, a button, and then there is a reject button. So everything is just very simply laid out on this screen and very easy to understand what you're doing. So
And then
operators didn't.
and then
What's
Ryan
that?
had mentioned before when it comes to downtime is that so there's really only 3 buttons on the screen at any given time.
Yep.
But then if the machine sits idle, we can set this threshold. It's you're able to set it to wherever you want. Right now we had it at 5 minutes. If 5 minutes goes by and there's been no new cycle started and it's been idle, the screen will change to our downtime categorization screen, and there it'll basically be just like 8 categories that are kind of our top level categories, or 6 categories that are top level categories. And the operator just has to touch screen. Okay, it falls into this category of operator not available. And then if there's subcategories like why wasn't he available? Was it lunch break or break, or you were
Cell meeting or something.
assisting another machine, cell meeting?
Yep.
Those options will pop up. They'll touch that, and now that downtime will be categorized. That screen will go away. It'll go back to the regular production screen. So at any given time, the training is very easy. It's very intuitive, kind of self-explanatory for most of the operators. They've actually been asking for, sometimes we've had them ask, hey, could I get this piece of information on this screen? Or where can I find like cycle time information is an option they can look at. So yeah, it's pretty straightforward and very easy.
Yep.
All right, looks like we got one more question in. Does MachineMetrics utilize crypto immutable ledger storage technology for sensitive tracking items like military or carbon tax credits?
We don't use crypto to store any data.
All right. It looks like that's all we have for today. I want to thank Ryan, Josh, Bill, Orchid Orthopedics, and MachineMetrics for making this webinar possible. And thank you to everyone for listening in. You should receive an email with a link to the recording soon. Thank you for your time and enjoy the rest of your day.
Thank you, guys.
All right. Thank you.
See ya.